I think for the US, it's a huge potential. 20 to 40% of electricity consumption provided by pretty much the West Coast.
This is EnergyCast, and I'm Jay Dowenhauer. Today we're talking about wave energy and the untapped potential for power under the big blue sea. Ashley and I just got back from our annual anniversary trip, and this year we headed out west for a week-long trip up the California coast. It had been 17 years since I'd been to California. Last time was when I was in college, and some fraternity brothers and I spent a summer over in San Diego. Not knowing anything about San Diego, we got jobs at SeaWorld, where we learned about marine life, the sea, and the importance of conservation. We were all from Louisiana and had bizarre accents, but the Californians thought it was cool, and so we all got jobs as tour guides for the animal exhibits. It's a little off topic, but my buddy Chris loves this story, and it's my podcast, so why not? So, it's our last day at SeaWorld, and we're going around the park to say our goodbyes. We get to the killer whale exhibit, and we ask the trainer if we can get a selfie with the whale. She blows a dog whistle, and this 11-ton whale comes swimming up. We get a few cool snaps on the fun saver, and the trainer takes off. Now, I'd just seen the Shamu show the day before and thought, hey, this whale is still at attention. Why don't I try a few hand signals I saw the trainers use? So I motion with my arms and the whale starts spitting water. I do something else and now he's flapping his fluke in the water. I felt like Neptune, the lord of the ocean, commanding this huge beast. Now, it felt like seconds, but it must have been longer because my buddy Jacques, nice SeaWorld name by the way, grabs my arms and goes, Jay, you need to stop. And I'm like, why? This is incredible. Maybe I should see if he'll jump. And then Jacques physically turns me around and about 24 park guests have now gathered behind me. Swear to God. So I do what any responsible employee would do. I say nothing. I put my hands in my pockets and I walk away. Like Bill Murray at the end of Caddyshack once he's blown up the golf course.
It looks like I'm a wreck. It's in the hole.
Now bear in mind that animals like a killer whale undergo years of intense training, and all behaviors are strictly reinforced with positive reinforcement. That's why you always see trainers tossing the whales fish when they've done a good job. I had no fish. The whale was expecting one, so I could have likely sentenced all the trainers to death at the mercy of a pissed-off killer whale. Chris, I hope you're pleased. I'm probably going to get sued for telling this story. So back to wave energy. This was an energy source I knew very little about, so I had to do some research. And when it comes to water power, there's hydroelectric, which typically refers to dams. We'll cover that in another episode. There is tidal energy, in which energy is created from the tides moving in and out. And finally, there is wave energy, which we'll be focusing on with today's guest. I'll admit, I'm a Louisiana guy, I didn't grow up around oceans, and I'm not an oceanographer. And frankly, I didn't know how oceans worked. Some of you, like me, thought waves for surfing were caused by the moon. It's more complex than that. Waves are primarily caused by wind. This confusion between the effect of wind, currents, and tides on the ocean led to my fundamental question: will this energy from the ocean be intermittent like wind and solar, or baseload like geothermal? More than likely it will be intermittent, but this resource is huge. The Energy Information Administration from the Department of Energy believes the coast could provide as much as 2.5 trillion kilowatt hours of electricity. That's about 65% of the energy consumed in this country. Would we ever reach that figure? Who knows? But so far, there are no commercial wave energy operations, so there's a lot of growth potential when you're starting from zero. Our guest today is Marcus Lehman, co-founder and CEO of CalWave, a wave energy startup based in Berkeley, California. CalWave made it on a lot of radars when it received one of the top scores in the Department of Energy's Wave Energy Prize. At the time, CalWave was developing what they call their wave carpet concept. Imagine a black conveyor belt with shock absorbers underneath. The whole apparatus rests below the surface of the water, and that up and down motion drives the carpet, which is attached to a pump, which moves up and down like a piston, creating energy. Marcus tells me they are moving on to a new design, which they are calling CalWave X, and they plan to take that design to commercialization phase. I hope you enjoy my conversation with Marcus Lehman. Here with Marcus Lehman, CalWave. Marcus, can you give us a little bit of a sense of what's going on in the industry? What is the status of wave technology today?
Yeah, so definitely still in the R&D stage. There is no installed capacity on a commercial level like offshore wind is. Wave is right now in a demonstration stage where several devices are being tested with the potential then to advance to a commercial project.
What sets your technology apart from other wave technologies unconsidered?
So our approach has the advantage that it covers exactly the same features a wind turbine has, and that's what we believe made wind successful. Current state-of-the-art turbine design reached a high performance, at the same time also high survivability. The wind industry found an effective mechanism to turn their blades invisible to the wind in storm conditions. That's being executed by so-called pitch and yaw control. And so exactly like that approach where the wind blades can become invisible to the wind effectively, we found a solution that can make a wave device invisible to extreme loads.
Your technology, I believe you call it your wave carpet technology. Explain to the layperson how that would work.
Yeah, so the wave carpet is how we started, and that's how our team formed around. It was a technology developed by UC Berkeley Mechanical Engineering, and we advanced it to a tank model. And in general, this is a technology that was targeting shallow water applications. That means similar to offshore wind, we were planning to use monopile mooring. And then the wave energy prize came along, which was nationwide technical competition in the United States that tried to identify the next generation technologies that in a large scale can become competitive with wind and solar and other generation forms. And this competition was mainly focusing on floating technologies. For the US Wave Energy Prize, we advanced that technology to a floating moor design that uses anchors. Currently, we call it the CalWave X, and that's what we're investigating right now.
I think wave power, we're thinking of something that's riding along the top of the water. Where is this in the water?
The wave energy density goes exponentially down with the water depth. So depending on the target site, we know exactly where to best operate. Right now, the most logical location we're targeting is in Oregon. They're working on a full commercial test site, and they have specific water depths that the site can accept. And so we're designing for these depths. And I think it's an order of 60 to 80 meters.
A lot of the wave energy technologies are typically on the surface of the water. What's the advantage of going below the surface?
Yeah, we saw it comes with a higher survivability in terms of breaking waves and slamming loads, as well as visual impact. We found that, especially the offshore wind industry had some challenges with visual impact. So operating fully submerged comes with that advantage as well.
How much energy do we believe a CalWave X could produce if it were commercial?
In terms of rated power, what we're seeing in the west coast of the U.S., the Department of Energy did a very good and updated resource assessment. And what we find in average is that a meter of coastline has an average of 30 to 40 kilowatts. And then depending on the performance of the technology, one can expect something between 30 to 60% of that, depending on the device performance capability. From wind turbine, for example, they're at 55% efficiency. I'd expect a fully mature commercial industry would reach similar performance levels.
You're talking about a linear straight line from the coast. Could you pack them deep?
That's a spacing question. If you look at a wind farm where you have areas of wind turbines, that took the industry a while to determine what's an ideal distance. And that has practical implications. That has maintenance questions. That has safety questions. And for wave, depending on rated power per device, that's to be determined. So I think what will happen in wave is similar to wind, that people will start small, and then on one point it becomes not economical for now, and then they would go with multiple areas.
I love the pictures you had of your tests. Those are on your website. Where are you in those pictures? It looks like the pools you would see at a NASA training center.
Close, actually. That was our final testing at the wave tank of the Navy of NAVFAC, north of Washington, D.C., and that was our final testing of the U.S. Wave Energy Prize.
And that basically simulates ocean current?
Ocean waves.
What will it take for wave technology to be embraced on the level of wind and solar?
That's a really good question, and we're looking into the history of wind and solar and why they are at the cost they are now today. What we found, what was driving the cost down is learning curves and mass production, as well as on maintenance and operational costs. The more installed capacity there is, and I think in the beginning of wind or solar in the 70s, 80s, and then when the cost came down in the last 10, 20 years, they were heavily subsidized. To get there, it was definitely driven by support mechanisms from the various governments.
You're in California, so one of the big questions I would be curious to know is, are there any environmental concerns with wave technology? You're placing technology in the ocean. Is it affecting any of the marine life? Has there ever been any concern about that?
Of course, with any construction project, you have to follow the guidelines and do very thorough environmental assessment. We know that the Pacific Northwest National Lab is very active in that area. They published a science report, as well as the Congress received a summary of environmental impact for marine hydrokinetics that includes tidal turbine, ocean turbine, and wave. And there was no high risk identified at this point of time. And then, of course, things like magnetic fields and others, they have to be monitored as these systems operate for longer, but we don't see a big difference from offshore wind. We're actually lucky in the sense that offshore wind is making so much progress, so we can transfer a lot of learnings that they made over to our industry as well.
Because your technology is underwater, would you see any issues with, say, fish colonizing or building homes around there, and that would reduce the efficiency of the technology?
Not so much, actually. Any floating technology also has a part that is underwater. I think the only thing that causes challenges is usually fast-moving part that the mammal can see, and in wave, we don't expect any bodies that will move faster than the perception of the local mammal.
Is wave technology intermittent, or can it be base load?
That's a good question, and that's where we're hoping to provide benefits to various locations, if it's on the island or microgrid.
What I'm asking is, when it comes to your technology, is there always movement creating some sort of current? Is the current creating current?
Not so much.
And you'll have to excuse me, I'm not from the coast. I think many of us maybe listening to this are not familiar exactly how the ocean works. Is there movement still going on underwater, even when there aren't necessarily high waves?
So we differentiate between various forms of ocean energy, wave energy being one of them. The others are tidal energy and ocean currents. The ocean currents, like the Gulf Stream, they're unidirectional currents that are driven by Earth rotation, and tidal energy is pretty much driven by the motion of the moon. So what we're using is actually the orbital motion. Waves are caused by friction of wind on the water surface. That's why if you look at the resource of waves worldwide, mostly the West Coast have the highest wave resource, mainly driven by winds traveling from west to east and building up waves there.
You mentioned current technology. Do you believe that would be more consistent than wave?
So these are just two different resources. One is driven by wind versus the other one is driven by the moon. Tidal energy also comes with the advantage that it's very plannable because it follows the moon patterns. And ocean currents, like the Gulf Stream, they're also very predictable.
Let's talk a little bit more about CalWave. Tell us your story. How did you get started?
Yeah, we started around a technology that was first investigated by Professor Alam here at UC Berkeley Mechanical Engineering, and then I joined his group around 5 years ago, and that's how we started working on the shallow water technology.
You first appeared on my radar through the Department of Energy's Wave Energy Prize. Tell us about that prize and where that got you.
Yeah, so the Wave Energy Prize was very helpful. I think without the prize, we would have not accomplished as much as we did. Also, it really helped us to focus on one specific aspect of the technology because we're essentially developing a new system, and there are a lot of technical challenges like optimization, costs, performance, specifications, and then also upscaling towards the demonstration. You can easily get lost doing all of these at the same time, and they're affecting each other. The Wave Energy Prize was structured in 4 different gates, and every gate had a focus on one specific aspect of that development path. And that really helped to do one step after another. And they also try to do a leaner approach where you completed a cost projection on the early stage right in the beginning. So that's what they found historically in the industry, that a lot of technologies upscale too quickly. And so there are ways to investigate that on a smaller scale with much less capital and time to build full-scale systems. Multiple devices were tested under the same conditions. So we all tested scaled prototypes. So I think that was a very great approach of completing such a, I would say, standardized test pattern for all contestants.
And to be clear, your team won the prize, correct?
So it was similar to the X Prize, and you could only win the prize if you would double the initial metrics they set. In the final round of the competition, they had 9 finalists, and we received the second highest score in that metric, so we got the runner-up award. What was your impression of the Department of Energy's enthusiasm for this part of the energy sector? I think for the U.S., it's a huge potential. There's a great report. The Department of Energy publishes called Quadrillion Report every 4 years that assesses the state-of-the-art industry as well as state-of-the-art resource. And there they found that the potential for the U.S. is significant. I think up to 20 to 40% of U.S. total electricity consumption is just provided by pretty much the West Coast and some portion on the East Coast. But it's a great way to gain energy independence and generate locally with available resources. And on top of that, we're seeing a high population density on the West Coast and same on the East Coast. It's a great locally available resource for the urban centers on the coastlines. Are there any other countries that are doing more with wave technology, like how we always think of Iceland when it comes to geothermal? Historically, the UK and coastal countries of the European Union have been quite active. And then we saw quite some activity in Australia and some in South Africa. There's a great resource called Ocean Energy System. They have an annual report, and that actually lists all the countries and last year's accomplishment. I think Korea and Asian countries become more active, more in tidal energy. But yeah, that's a great summary report of all the different local activities. How is CalWave trying to enter the commercial phase of operations? We're currently preparing for ocean demonstration, and after that we would follow a similar track than the wind industry did, especially the offshore wind industry is gaining a lot of momentum. We see a lot of installed capacity. I think in Europe, just in the last half a year, there was like 3-digit megawatts were installed. And so that took a while to get there, and that will come with operational experience, reaching multiple units that brings the cost down. And so we have the advantage of having wind and tidal as kind of our bigger brothers and sisters we can follow on a similar trajectory and reaching larger commercial installations. Are you having conversations with the utilities? In general, good question. Utilities adopt technologies that are proven, and power outages and reliability is very important, of course. We're seeing more and more utilities also participating in demonstration projects. And in the best case, for a larger commercial demonstration, we would partner with the utility that provides, for example, a power offtake agreement and is also interested in learning the advantages of our approach and the resource in general. The large utilities out there in California, have any of them had conversations with you guys? Yeah, so there's PG&E. They actually received a grant from the Department of Energy a couple of years ago to investigate utility-scale farm of wave converters called the Wave Connect study. And we're in regular exchange with various departments of utilities that are general technology scouting and seeing what new technologies will become available to the utilities. So that's good to see that they're really trying to get a better understanding of what will come to the market in the next couple of years and prepare for that. I always ask companies that are in the development phase, working toward commercialization, what is the low-hanging fruit for you guys? What is the most accessible path to commercialization, you believe? These will be, of course, locations where there are already infrastructure in place and existing test sites, like the one they're currently developing in Oregon, or several available in Europe, and locations with high electricity prices at remote locations that are really dependent on fuel imports, water imports, and others, so they have the biggest pain point. I spend most of my time doing water treatment. My last question is, on your website, you also mentioned that your technology could desalinate
saltwater, right? Tell us about what your plans are for that application.
Yeah, essentially we learned that the biggest expenses of the desalination plant is providing high-pressure salt water. Instead of running a generator, we could also run a pump and provide high pressure to a desal plant, depending on the size of it, so that one could skip the efficiency losses of going to electricity and then going back to a pump. One could directly go to a pump and provide process power to a desal plant. Logically, the locations that have good resource for wave power usually also are lacking water in these remote locations.
Marcus, I'm going to wrap up with my lightning round of your thoughts on different energy technologies. The first one is natural gas.
Natural gas is going to be used for gas turbines, which have the advantage of being faster than a coal power plant. So we're seeing, especially in grids where there's an increase in renewables, we also see an increase in natural gas consumption for these faster backup power plants.
Crude oil.
I think it's a finite resource on the larger scale of timeline.
Nuclear.
Another form of electricity generation that is very baseload and comes with challenges of waste storage, I think is the current debate.
Coal?
Coal has been historically a big source of our electricity production and is a finite resource of fossil energy.
Wind?
Growing source of electricity production.
Solar?
Well reached in the last 10, 20 years, larger commercial scale, and has a huge potential for providing sustainable electricity in the long run.
Biofuels.
Waste fuels can be used for also electricity production or other sustainable forms of material production.
Fuel cells.
Mostly investigated for mobility using other forms of stored energy, mostly for the transportation sector because they can use a very high, dense form of stored energy.
Hydroelectric, and because you guys are doing wave technology, how about we do your thoughts on conventional hydroelectric like dams first?
Yeah, my professor that was supervising my master thesis, he used to be the CTO of one of the largest turbine manufacturers, and I always liked his statement where he said there's no other product or engineering solution, if you want, so where as much thought and manpower went in than hydro turbines. It's a very mature industry producing a lot of power worldwide and essentially being used for storage as well. So still great potential there, but I think most of the resources are already being used. So yeah, potential to grow is unfortunately limited.
And then the other part of hydroelectric, wave technology, your technology.
Wave technology can provide additional local and renewable power, mostly to coastal communities and urban centers as the industry reaches maturity.
Geothermal.
Depending on existing infrastructures, sometimes can be cost competitive, and I think it's also being investigated in various locations.
Electric vehicles.
I think the automobile industry actually started on electric vehicles, and now as the battery costs go down and electricity prices also go down, become more attractive for sustainable transportation.
And then finally, nuclear fusion.
Yeah, also is a opportunity to reach a form of at least not fossil fuel-based energy production, and it's been investigated since the 70s and has enormous potential, but will mostly be applied in a centralized grid. So for decentralized solutions, fusion has limited potential.
All right. Marcus Lehman, thank you so much for your time.
Yeah, thanks so much for calling your interest.
That was Marcus Lehman, co-founder and CEO of CalWave, a Berkeley, California-based startup developing commercial wave technology. Marcus got his master's in engineering from the Technical University in Munich and found his way to Berkeley in 2012, where he eventually formed the company in 2014. We hope to hear a lot more on the progress of his CalWave X technology in the future. Marcus appears in a presentation which you can check out on YouTube. I have a link to that at energy-cast.com. I'll also post a bunch of pics on Instagram at Host Energy. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 17. Be sure to join us next week when we explore a radical new wind turbine design from the unlikeliest of places, amusement park rides. Yep, that's right. I can't wait for you to see this. Until then, I'm Jay Dowenhauer. We'll see you next time.